Right, now let us continue with total surface area for cone. We are at page 4 of worksheet 9D. If you manage to look at ACE Learning net of a cone video clip, you should be able to visualize how does the cone look like, okay, for the net of the cone. So one simple example is to get a piece of paper. Okay, how to make a cone? Get a piece of paper, you can draw a circle. Okay, remember to mark down the center of the circle. Alright, cut out the circle, but before you cut out the circle, let's draw a random two lines, random two radius, maybe one here and one here. Okay, what do you think Mr. Liu is trying to do? I draw a circle, I draw two radii. What I'm going to do next is I'm going to cut the circle out. Okay, be patient, let me cut the circle. You can try this as well. Let's take a piece of paper, draw a circle using your compass. Then I draw two radii. Radii is the plural of radius. So once I got the circle cut out, okay, throw this away. Once I got a circle cut out, these two radii, right, I cut along it, I will get a Pac-Man. No lah, just joking. I don't think you know what's a Pac-Man, right? Oh, here comes my background music. Don't worry, Mrs. Liu is taking care of her. Okay, so now you have two, we call these sectors. Okay, you learn in Sec 3. You learn in Sec 3 that this is called a major sector, this is a minor sector. You know, for both of them, if I roll them, what will I get? A sector, right? Both of them are sector. If I roll them, where the two radii meet each other, for example, these two radii meet each other, right? What do you think I'll get? Okay, it's quite difficult to roll it up. Okay, if you roll it or you use a scotch tape, you roll it up, you will get a, okay, not very nicely done, but you actually get a cone. It's not very clear here, but actually you will get a cone. Okay, you will get a cone. So of course this cone as compared to this will be smaller, because if you take a look, now Mr. Liu is going to combine this radius and this radius. They are going to meet each other. I will form a bigger cone. Take a look. These two radii meet together. There you go, you get another cone. You can try it at home. You can make a hat for your pet. I don't know. See? A nice hat. A cone. Can you see that? Alright. So actually a cone is made up of sectors. Okay, these sectors are either this shape or this shape, right, will form the curved surface area. So you draw either one. You can draw either one. So for simplicity, I draw the smaller one, easier. So the smaller sector, draw a space there, draw here. I think it's too big. Okay. This is a sector. Remove it. Then after a sector, this length over here, in Sec 3 you will learn that this is called arc length. When you fold it up, remember, when you fold it up, it becomes a circle, right? It becomes a circle, right? So I still have to draw a circle, the base area with this base. I have to draw it. So let's imagine here. Let's not draw freehand, let's be more professional. Use a compass. Let's draw a circle. Touching the sector. Oops, sorry. So clumsy at night. Okay. Just draw a circle. Alright. So the net of a cone is a sector and a circle. Okay, I hope it's clear. Okay, now let's study the curved surface area of a cone. Refer to ACE Learning curved surface area of a cone. Again, click on this when you say curved surface area of a cone. The formula given to you, if you didn't copy down, is actually pi RL. The way I write my L is slightly different, right? Okay, I write a very sexy L, you know, curve this way. Why is it so? To represent the slant height. Okay, it's to represent this slant length lah. Okay, so I represent it by L here. Okay, so the formula for the curved surface area, which is actually this, okay, is pi RL. Here so total surface area of a cone, of a closed or solid cone. Then you must add the base, right? Okay, so it's pi RL plus a circle. The base is a circle. Okay, let me be more specific. This is pi RL. This is pi R square. Alright, the area for the sector is pi RL. The area for the circle is pi R square. This fan-shaped looking thing is called a sector. Okay, it's called a sector. You will learn in Sec 3. Okay, let's move on. So can you remember the formula? Pi RL and pi RL plus pi R square. Okay. So moving on, again, there are 3 examples. Example 3.1, 3.2, 3.3 and 3.4. Okay, ACE Learning under volume and surface area of a cone. Please go and look at their example and fill out the blank. Do this question. Example 3.1. Let's check whether you copy correctly or not. They ask for curved surface area. Just apply the formula. Pi RL, sub in 4, sub in 13. Because radius is 4, height is 13, slant height is 13. I get 52 pi. Why did I not evaluate the answer? Because the question asked me to leave in terms of pi. Okay. What about the next question? Total surface area. Total surface area of a cone is pi RL plus pi R square. Previous answer is 52 pi. Just write down. Pi R square. The radius, if you take a look, is 4 cm. Sub in 4. 4 square becomes 16, so 16 pi. 52 pi plus 16 pi is 68 pi cm square. Answers live in pi. Oh, sorry. I'm pointing, but you cannot see. Answers live in pi. So sorry. Okay. 68 pi cm square is the answer. Alright. Let's move on. Next example. 3.3. ACE learning as well. The slant height of a cone. This question is slightly more difficult because they didn't give me a diagram. The slant height of a cone is 9 cm and its curved surface area is 150. What is the radius of the circular base? Correct answer to 3 significant figure. Not very sure. But just apply the formula. Curved surface area of a cone is pi r L. I'll just write down. Curved surface area given 150. Write down. Then let's see what else is given. Oh, slant height L is given. Write down 9. What do they want? They want radius, right? Since pi is we have the value of pi right in your calculator. Yeah. So why not we just bring 9 pi under 150 to solve for r. In other words, 150 divided by pi divided by 9, like that. You can get r alone on one side. Press our calculator, you get 5.31 cm. This is the rounded off answer, rounded off to 3 significant figure. Okay, last question. Example 3.4. Again, difficult because they didn't have a diagram, but you have to visualize. Oh, sorry, this question they have diagram, but they didn't have the L, the slant height. Okay, how to do? Okay, if it's slightly more difficult, you write down whatever you have. Question give me diameter, I write down. Question give me curved surface area, I write down 63 pi cm square. Curve, oh, did I write wrongly? Let me take a look. I think there's a mistake here. Yeah, I think there's a mistake in the question. It should be 63 pi. Because I copied this from the ACE Learning answer solution. This should be 63 pi. Okay, please change. So curved surface area is 63 pi cm square. So curved surface area formula is pi r L. Curved surface area replaced by 63 pi. Replaced by 63 pi. Then let's see what else I know. Both sides have pi. Both sides have pi, cancel away. So 63 equals to RL. R I have. Because diameter is diameter of the circle. This is a circle. 3-dimensional figure, so this is a circle. The diameter is 14, radius must be 7. 14 divided by 2 give me 7. So replace R by 7. I want to find L. 63 divided by 7, I get 9. Right, please copy down. This should be it. Okay, that's all for this part 9D, worksheet 9D. Later on, I will share with you the homework 9D.